and that is the best way to go through or to know the properties of electromagnetic spectrum by studying different types of waves and how do they behave. For example, radio waves are the longest wavelength, and radio waves which are longest in wavelength, that is why they are not they are used for communication process, the communication purpose, because they can be sent to very long distance and they mostly pass through body, so they do not possess any health effect. So they are not strongly absorbed and thought or no effect on the health of living tissue. Microwaves are radio waves with short wavelength. Short wavelength means a bit more frequency, that means some sort of energy is associated with them, a bit more than what radio waves have, and due to which they can be absorbed by body and cause a minor heating effect. Minor heating effect, but they are not hazardous, they are not very dangerous for normal human beings. Microwaves produced by mobile phones have not yet been declared that they possess actually adverse effects on health. Now, infrared waves are absorbed by skin to some part. We have different layers in skin, epidermis, then there are more names, biological terms, but anyhow, infrared waves are absorbed by the skin up to some extent, and these are what? They are detected by nerve endings in the skin. They are heat sensitive nerves. For example, when you stand in the sun, we actually feel the heating sensation on the skin. That is because of that we have those heat sensitive nerves on the root level of the skin, and they detect the heat. So if infrared waves, if they are exposed for a long time, suppose this is a portion of meat and infrared waves are exposed to it for a long time, it will burn it, right? Because infrared waves do have this heating effect, right? Skin is exposed to too many high energy infrared waves, skin may get damaged. Some people do get sunburns, right? Sunburns, or when they work, some factory workers, when they work in the very heated environment, they do also get skin burns due to same thing, infrared radiation. One more thing, infrared radiations are emitted by every single body which is having some sort of heat. For example, the light bulbs which are projecting light on my face right now, they are getting heated up. So if right now in this room, in the studio, we are having some infrared binoculars which can see only the infrared negative, you know what I mean. There are infrared cameras. The normal camera see what a human eye sees, but an infrared camera will see the infrared radiation, that is the heated part. So water which is very high in temperature will be black and then red and then so on, and which is not in heat, which will be whitish, some sort of color. So right now my whole body, whole face will be very red in color in that camera, because I'm speaking, so I'm getting exhausted, more blood circulation towards my head, that means more heat emitted out of my face. This is why. So the point of telling you all this is that infrared radiations are emitted by every single body which has some sort of heat associated with it. Eyes detect visible light which does not, obviously our visible light do not possess any health risk to us, right? But if eye is exposed to very high intensity light, yes, it can affect us light. That is why we are advised not to look at sun through telescope or binoculars, because that means we are looking at a large portion of concentrated rays which can definitely damage our eyes. Now, lasers, we all have seen lasers. Lasers are what? Lasers are concentrated light rays. So this is a laser, right? So it has a very concentrated sort of intensity. So this concentrated energy, that is why they can travel up to a very large distance, right? Now, so they can also affect our eyes. If that is why we are supposed not to play with lasers. We are not supposed to put directly laser in someone's sight. Also, lasers are used, in some countries are used to cut metal bodies. So you can actually imagine how powerful radiations it might have, right? The intensity. How can it do so, by the way? See, laser light has the very high intensity, that means they have very high what? Energy. That energy is doing what? The energy is getting transferred to the atoms and molecules of the metals, and those metal, it is actually getting what? It is getting what you call melt. It is getting in the melted form at the portion where it is exposed to the infrared radiations, right? Some very powerful lasers can cut through materials, so they would also be able to cut through the living tissue, so that is why dangerous. Now, how do ionizing waves affect human beings? There are some sort of ionizing waves. What are ionizing waves? which have higher energy, that means of higher frequency. What are the electromagnetic spectrum part of having higher frequency? X-rays, gamma rays, right? So let's see. First of all, UV rays. UV rays are absorbed by the body mostly. Skin has some sort of pigmentation which protects the skin from the dangerous part of UV rays, but yes, they can ionize skin tissue, right? They can also cause skin cancer, right? Then X-rays, they usually pass through soft body tissues, but they are reflected by the denser bones, so they can ionize bones. So the denser part of the body, or the thick material, for example, what do you call between the joints? It is cartilage. So yes, they can affect cartilage as well. Then gamma rays can definitely affect human tissues because they have the highest frequency, that means highest energy. These are some of the terms which we'll be going through again, some terms, some definitions. Absorption, that is the part which is absorbed in the matter on which the electromagnetic spectrum or the electromagnetic waves is exposed. Electromagnetic spectrum means the order of wavelength or frequency in which we have all the different type of electromagnetic waves. Then frequency, number of vibrations per second, nu 1 upon time period. Gamma rays of highest frequency electromagnetic radiation. Infrared waves which produce sensation of heat, which produces heat. Then microwaves, which are short wavelength radio waves, right? Electromagnetic waves, radio waves are the longest wavelength used for communication, reflection. We know that wavelength is also something we know, distance between two consecutive crust and trough. Then ultraviolet rays, which can be absorbed by certain chemicals and emitted as visible light, right? This uses include tanning beds and security marking. Ultraviolet rays are used in security marking, right? Visible light, we know. X-rays, we know it is that part which passes through most of the materials. It is used for security purpose and all. This is a simple diagram which shows how electromagnetic wave propagate. We have electric and magnetic field in mutually perpendicular directions. So this is the direction of propagation right now. So I have shown only one direction, but it might have many different directions, right? So when an electric charge vibrates, the electric field around it changes, creating a changing magnetic field. Hence they both create each other simultaneously. The magnetic and electric field create each other again and again. An electromagnetic wave travels in all the directions. Here in the diagram, the wave is traveling only in the one direction, right? Electric and magnetic fields vibrate at right angles to each other. We have discussed it, and that is why this is called a transfer of waves. So let's go straight to the properties of electromagnetic waves. All of the properties have already been discussed, so we'll go a bit fast here. All matter contains charged particles that are always moving. Therefore, all matter are the source of electromagnetic waves, right? Any matter any particle which is moving or vibrating, they can produce electromagnetic wave. Wavelength becomes shorter as the temperature of the material increases. Why? If the material's temperature increases, the vibration or the frequency will increase. Frequency increase, that means the wavelength will decrease. Electromagnetic waves carry radiant energy. That's how they transfer energy in the radiation form. Can a particle be wave? Electrons, when fired through two single slits, this is what they form. So basically, electrons have dual nature as well. They have particle nature as well as wave nature. This was being seen in interference and diffraction, and we have studied that in optics, right? This diagram will actually give you an idea about electromagnetic spectrum size. For example, here, radio waves, the wavelength of radio waves is of the size of building. That means 10 raised to the power 3 meters. 1000 meters or 1 kilometer, even more than that. So radio waves have very large wavelength, whereas microwaves have the wavelength of order of size of human beings. Infrared has the wavelength of size of what? A butterfly. So we are getting smaller and smaller. Visible light has a wavelength of the order of the needle point. You have needles in our homes, so the tip of the needle from that size to the size of protozoa. That is the size of wavelength of visible light. Then ultraviolet light have the size of molecules, and even smaller, X-rays have the size of the atoms. All molecules contain certain atoms. One single atom, that is the size of X-ray. And then gamma rays have the size which is actually equal to atomic nuclei. So we are going further deeper, further smaller. This is the value of frequency and the temperature of object at which the radiation will fall. So temperature can increase, right? Substantially. Next, The part which is low in frequency, that is up to radio frequency to visible light, even up to some extent ultraviolet light, they are non-ionizing in nature because of having less energy. And those part of radiation, those part of electromagnetic spectrum which is high energy are ionizing radiation. They are prominently X-rays and gamma rays, but sometimes they are ultraviolet radiations as well. These are again the order of frequencies of all the rays. Now we are going to study about different types of different parts of electromagnetic spectrum, and we are going to discuss few more properties with them. For example, what are microwaves? These are radio waves of wavelength less than 30 centimeter, higher frequency, shorter. Where do we use it? Cell phones and satellites use microwaves between 1 centimeter and 20 centimeter for the propagation, for the communication purpose. Microwaves are radio waves. One more thing, microwave ovens, a vibrating electric field is used to do what? We have just discussed it, to vibrate atom or moisture content inside the food present, and that is how we heat up the food. How does radar work? What is radar? Radar is radio detection and ranging. Same as sonar. What is sonar? Sonar is used in ships, the battleships or submarines. Sonar is sound navigation and ranging. This is sound navigation and ranging. Both sonar, dolphins use the sonar technology. Both sonar and radar are the techniques which is used to know the exact position and location of an object. And how it is used, they both work on the same principle, that suppose this is our radar, this is a hilltop, we have a radar here, okay. So this radar will emit radio waves, and if there is a flying object here, I am trying to make an aeroplane, but okay, this will do. If we have a flying aeroplane, obviously aeroplane must be flying at that time. So these waves are reflected from the object and are received back to the receiver. So by measuring the time lapse, because this is a continuous process, the whole thing goes like this, and the same continuation, in continuation, the reflected and reflected back rays are being observed by the receiver here, and that calculation gives the exact position, height, speed of the moving aircraft. This is radio detection and ranging. Same applies with the sound navigation and ranging, that is sonar. So this is what dolphins do in between, like this is a seashore and this is a ship. So it will send signals here, and if something is present here, these waves are reflected back and received at the the instrument located here, and they'll again get the exact size, and if it is moving or not, the other position related thing with respect to the point from where these rays are being reflected. So this is radar. Infrared, we have discussed a bit about that. Infrared causes heating effect, right? So electromagnetic wavelengths between 1 millimeter to 750 billionths of a meter. Then they used our daily remote controls, CDs. Then in our mobile phones, everywhere we are using the infrared waves. Every object gives off, yani that means it emits radio waves. It emits what? Infrared waves when it is heated up, when it is having a bit higher temperature, right? One more thing. Hotter objects give off more than cooler ones, obviously. Satellites can ID types of plants growing in a region with infrared detections. How does satellite does so? See, the amount of water content inside a plant also gives the amount of heating produced inside the plant, and that is how satellite can measure what is the breeding response of a plant in particular area. Ultraviolet rays, we have studied about then, that wavelength from 400 billion to 10 billionth of a meter. Enough energy to enter skin cell, and exposed radiation for more duration can actually cause damage in the skin. Sometimes UV rays are also responsible for the skin cancer, right? UV radiation can be useful. They can be useful to some extent if they are used to sterilize medical supplies and equipments, because our body also receives UV radiation to make vitamin D, right? We know that which is healthy for bones and teeth. Detectives use fluorescent powder which absorbs UV radiations, and they expose the fingerprints. For example, I have my fingerprints here, then some sort of powder will be sprayed on it, and UV radiation will actually glow the markings clearly. So that is how we can take out fingerprints in crime scene. Ozone layer. What is ozone? Ozone is oxygen layer, which is O3 layer, right? So ozone, having a bit denser in value, they reflect most of the UV rays which is coming from sun. But due to the depleting value of ozone layer in our atmosphere, it is becoming more and more like that is our planet, that is Earth is getting more and more vulnerable to UV radiations, and that is causing a lot of health related issues in human beings, plants and animals, right? O3 molecules atoms, ozone layer is decreasing due to CFC. What is CFC? Chlorofluorocarbons. It is present in AC perfume. Chlorofluorocarbons, how does they affect ozone layer? They actually, these particles actually interact with oxygen atom and they make O3 to something else, or O2 or single or nascent oxygen, right? So this is how they are depleting ozone layer. X-rays and gamma rays, electromagnetic wave with shortest wavelength and higher frequency, both X and gamma. High energy go through skin and muscle, but they are reflected by the denser bones. Higher level exposure can cause cancer, right? Now, the composite image, this composite image shows the all sky gamma ray background. This is the gamma radiation when, this is the exposed version of Earth's exposed version of when sunlight is entering Earth. So this is how it looks like where gamma rays is maximum, right? Now we are going to watch some images related to how electromagnetic spectrum, that is different parts of electromagnetic spectrum, are used in medical science. For example, radio waves. They are used, medical science, I'm getting to that point, but radio waves are used in mobile phones, right? So microwaves are used, microwaves are part of radio wave, and radio wave are used in what? We use it to cook food or heating effect of food. Radio waves are also used in mobile phones, right? This image, it is an image which shows 0.2 degrees Celsius increase in temperature, the reddish part in the brain after a prolonged use of mobile phone, right? Then infrared radiations, which is used to heat food, but in medical science it is used in pulse oximetry, and it is used in where? This is pulse oximetry indicators and near infrared spectroscopy, where a child is allowed to watch black and white squares on the screen, and hence due to which the brain works something, the brain starts working and blood flows more towards the brain, and that produces heat inside the brain, and which is measured by other devices. This is called infrared spectroscopy. Then we have thermography. Thermography are thermographical images. Thermographical